Are we good?
Yeah.
Okay. This is, again, practice midterm part 2, questions 30 through 40. And this, you're asked to classify the following statements as either A, true, or B, false. Okay? And the first one is number 30, and the statement is, it is impossible to lick your own elbows. Okay, now I suppose I should explain the purpose of this question. This is pretty much put in there for sort of comic relief. It turns out that if you ever actually try it, it generally is true. But as I've found, because I've been asking this question for years, there is the exception. There are people who can lick their own elbows. Most of us mortals can't, but if you happen to be the right kind of double-jointed, it is true. With a question like this, if I put something on there for comic relief, you can pretty much bank on, I don't care what your answer is, you're going to get credit for it. So it's just there to lighten up and let you feel relax a little bit on the test, and you'll probably perform better. So I don't care what answer you can put here, A or B, either one will do. Okay, because actually it is pretty much generally impossible, but there are exceptions. Now, number 31, metals form basic oxides. Well, this is essentially, we're discussing the homology of metals and nonmetals, and we're going to be refining our homology of the periodic table, which is just a study in homology. Homology being the way that things transform, and one of the characteristics that we use because all of the elements in the periodic table will form compounds with oxygen. They will combine with oxygen to form some sort of a compound. And there is a singular distinction between metals and nonmetals and the type of oxides they form. Metals form basic oxides, or what we call basic anhydrides. There are materials that, when placed in water, will produce a basic solution. And so, in contrast, nonmetals form acidic oxides or acidic anhydrides when placed in water. So once you understand that, this is the way they transform. When they combine with oxygen, they transform into a material that is going to be a basic anhydride or a basic oxide. This is true for all metals. And that's the beauty of it. That's the power of homology. Once you understand the homology of one member of the group, you know automatically by default the homology of all members of the group. So this is a very useful tool in our study. And metals do indeed form basic oxides. So the proper response is A. Number 32. There is a preferred degree of freedom in every sample. Well, this goes to our understanding of what a degree of freedom is. And for every type of energy, there exists a degree of freedom. And so there does not exist any preferred degree of freedom. In fact, there's part of when we go to study the Boltzmann distribution or Boltzmann's law, or any statistical property, we came up with the equipartition of energy. And the equipartition of energy is pretty much a result of Boltzmann's law. That means that the energy is distributed equally to each of the degrees of freedom available to the molecules in the system. And so that means there is no favored degree of freedom that gets an unfair share. And an example would be the kinetic energy. The kinetic energy, there are 3 degrees of freedom for the kinetic energy of a system of molecules, like, for example, the gas molecules in this container. If there was in other words, we can decompose their motion into three possible directions. I can call it the x, the y, and the z direction. And their motion, or their velocity, or their kinetic energy is equally distributed. There's the same amount of energy distributed in each direction. There is no preferred direction. If there was, then we would see this, that if all of the molecules were moving in this direction, then when they collided with the wall, this would move. Or if they were all going up, it would be Wingardium Leviosa. It would levitate. And the laws are pretty much the statement of what we've observed in experimentally reproducible conditions. And there is no exception to the law. And nobody has ever actually observed reproducibly in an experimental condition any preferred degree of freedom. Otherwise, we would have experienced this our whole lives. And as romantic as Harry Potter is, and to think that there is this special, chosen direction, and with the bright magic words, I can say Wingardium Leviosa, and we'll all start to do that. In practice, it doesn't happen. And so, brings us back down to earth. And there is no preferred degree of freedom. B. Okay. Now, number 33. Liquids have a fixed shape. Well, here's a liquid. Here's another one. I'm not going to do any more with it than this because I don't want to get wet. But you can see, obviously, that's not true. One of the defining characteristics of liquids is that they do not have a fixed shape. They do have a fixed volume. Gases have neither a fixed shape nor fixed volume. Solids have a fixed shape and a fixed volume. So we can distinguish between the various states of matter. This is, again, homology. This is some of the this is a defining characteristic of how things transform, and this is well, I guess it would be homology to a certain extent. Yes, this is the type of things that this does. It's a bit more of its dynamic. How does it? It is not a fixed shape, and all liquids have that in common. Fixed volume, not fixed shape. So this is false. Okay? Now, number 34. You tried to lick your elbows, didn't you? And this is usually on the test I've given in the past when I have these two questions. You can't have the first one without the second one. And I usually put the second one on the next page so you don't see it in case you read ahead. So that I can, and I have actually seen rooms full of people take this test, and some people do try to lick their own elbows. Some people don't, but a lot of people do, and that's why I put that in there. And it doesn't matter. Either answer will be adequate. This is for comic relief. Okay, I know I'm not that funny, but I put it in there anyway. Now, problem 35. The significant figure convention applies to all measured quantities used in a calculation. This is another defining characteristic of the convention. We only apply it to measured quantities. The quantities that we use, for example, to convert from one unit to another, from miles to kilometers, or from inches to furlongs or meters, these are exact numbers, and it's transparent that those numbers do not, the significant figure convention does not apply to those. It only applies to the measured quantities used. And so it reflects the precision with which something was measured. And this is the actual, pretty much the heart of the significant figure convention and how we use it. And so this is indeed true. So that's A. Now,